Hello, welcome to the channel. So today I'm really excited about the topic and I hope you'll learn quite a lot from the video. So we will cover things like Debezium Kafka connectors and test containers to do the end-to-end testing. So our final goal will be to implement a test that will start a database. It will start Kafka and Kafka Connect in own containers, and then we'll register a Debezium connector on top of that. And when we insert our record into the outbox table, it will be published to a topic in Kafka, and then in the test we'll listen to that Kafka topic and we'll see the message coming through the Kafka, through the whole pipeline. So it's really handy if you're using Debezium connectors and you want to write tests. But let's start with just an overview, because I believe that could be a lot of new things for a lot of people. So let's start from basic. So imagine we have a service and we have our own small database, let's say like relational database that we use as our backend in our service. And then we want some asynchronous communication between the services, and we decided to use Kafka as the message broker. So now when we store some changes in our microservice, we want to publish a message to the Kafka topic so other services can listen to it. If you just start thinking about that, like what's the easiest way to do that? You just grabbing the Kafka producer and on some change in the original service, you produce the message. But straight after that, we have a problem, because your service in your business logic, you want to write something to the database, to their own database. At the same time, you want to produce the message. But you want to be sure that this is like an atomic operation. You want these two operations to succeed or fail. And once you write your Kafka event and then something is failing in your code, it's kind of impossible to delete the message from the Kafka. So the idea of connectors on top of database is basically you don't write straight to Kafka. You work with your database, and then you have connectors that listens to changes in your tables or in some specific tables that's supposed to represent outgoing messages to Kafka. And then you can rely on database transactions, right? So you wrap your piece of code in a database transaction that covers your change, some other tables, and it can fail, it could be reverted and all that stuff. So yeah, that's good. We have now Kafka Connect. We have some kind of connectors registered to listen to changes. The question now is what type of connector to use. And if you start searching that topic, the top result will be something like JDBC connector. And there are different types of that, but they basically doing the same thing. They rely on polling. So once in 1 second or whatever, like milliseconds, your connector will execute a query against your database. And in the query, you can specify logic how to get updates or like new events from your table. And that could have different mechanisms like sequence IDs, created add fields, and all that stuff. But really, at the end, even if you solve all the problems you're happy with all these limitations, eventually you'll end up with something like that concurrent transactions will still cause problems and you can still lose events. And it's too much to cover in this YouTube video, but if you want to understand all the problems with JDBC connectors and all the limitations, I highly recommend this talk. It will describe everything that could go wrong, and give some insights. So I highly recommend that. So yeah, and all the links to all these things will be in the description and also in the source code of the repo that we are going to work on today. So yeah, watch this to understand why JDBC Connector is probably not the ideal solution if you rely on this mechanism to publish all your changes to Kafka. So yeah, what's the alternative? And there is a project called Debezium. So that's the website and lots of documentation, so you can go through that. And it supports various types of relational databases, and actually not only relational, like MongoDB is here as well, Cassandra. But my experience is kind of limited to Postgres, as we use it as our main database type. But yeah, how this is different from JDBC Connector. Again, not too much in details, but the mechanism is different. So in Postgres, for example, there is a thing called write-ahead log, where basically you have all your information that happens in the database as a log, and there is an API that you can subscribe to and get the changes from the write-ahead log, and it eliminates a lot of problems. So everything that happens is written to the log, and you can get it from there. So you don't have a majority of problems that happens in JDBC connectors. The downside is that it's a bit more tricky to configure, but once you've done that, that's fine. So once you have Debezium Connector, you are solving the problem of putting messages from your database to Kafka topics. But the raw format is probably not what you want. And also, if you decided to use some event sourcing, probably you don't want to listen to your changes in your database tables, but you want to go with something called outbox pattern. And there is an outbox event router transformation available. And also, let me quickly grab the link. So yeah, again, all links are here. So check this one as well. It's the pattern is described here. So let's take a look into the picture. So we have our microservice for the orders, and then we have two tables now. One is like the main one, orders, when we store our view of the orders. We can update rows here and all that stuff. And on top of that, we have outbox table. And the outbox table format is something like ID, aggregate type, aggregate ID, type, and payload. And payload is actually like a JSON-B field. So we can put any data we want there. And actually, this outbox table is what will represent outgoing events to the Kafka topic. And also, outbox pattern in Debezium will support splitting events into multiple topics. So that's configurable, but by default, it will use the aggregate type. So it will generate topics. By default, it will be something like outbox.event.event aggregate type. So it will be order or customer. So we already will split this into multiple topics. So our consumers can decide which aggregates they're interested in and subscribe only to those messages. So the types are more specific, like order created, order detail cancelled, and all that stuff. And the idea is that when we write some change into, or like insert the row or write some change into the orders table, we wrap actually that into a transaction, and in the same transaction we do insert into outbox table of event that we want to be published in Kafka. And again, as that's in transaction, that will be atomic, and we know that we have a guarantee that if something updated in the orders table, we created related event in the outbox table. So after that, we have Kafka Connect, Debezium with outbox transformation, and then we have that listening to the outbox table changes, and then we publish events to Kafka. Then we have a couple consumers that listens to the events from those topics. So that's overall. Again, this is a good read. There is also, if you're a Java user, there's Java Quarkus extension that supports outbox pattern and Debezium thing out of the box. But today, the topic is actually to try to reproduce that as a test. So we can experiment with the pattern. We can change some connector configuration and see how that works. And yeah, as you can guess, we'll do that in Clojure, but nothing stops you to do that in Java because basically all the libraries are available there. Yeah, so that's the page we'll mostly follow. But after that, we'll try outbox pattern on top of what's described here. Note that this is in experiment mode so far, so use at your own risk, I believe. Couple dependencies that we need. This one is the main one to register connectors, Debezium TestContainers, and then we'll have our Kafka from TestContainers and Postgres. I can actually go here and show you the project CLJ. So we have Clojure, TestContainers, some stuff related to database. So we'll do some queries, some inserts, and then JSON library. This Jackdaw is actually just Kafka streams, but we will use the test functionality from that to create consumer and wait for the events. Then we have some logging, Kafka test stream utils needed by this library, and then our containers for Kafka and Postgres. So let's move into our main test. So regarding setup of the connectors, we need to create a network that all goes from TestContainers classes here, the network. And then we create 3 connectors. One is for the Postgres database, then for Kafka Connect, and wait a sec, should be Kafka somewhere. Yeah, and Kafka here. And then we have this function to start all containers. There is a utility in TestContainers called deep start, but basically you can do really just loop through this and call start on top of that. But basically this is returning a future that you can block on. And then I created a simple fixture with TestContainers. So we basically just starting containers, then running our tests, and finally we loop through those and stopping them. And then I register this as with TestContainers. We can ignore this one, but it's basically just getting connection to our TestContainer database. And for the test, we'll need our outbox table. So it will be ID, UID, aggregate type, aggregate ID, type and payload, and also this extra field when the record was inserted. This naming is just because Debezium Connector will expect these names as defaults, but you really can use whatever you want here if you don't like this name or you want an underscore or whatever. And there are properties to override that in connector configuration. After that, we have our outbox insert function that will help us insert the event into the table. A bit of HoneySQL here and Next.jDBC. Yeah, so let's go to the test and start from the top. So let's see. We have our data source to connect database. Then we just creating a table here. In real world, we'll use some kind of migration mechanism for your database. And then we have the register Debezium outbox connector function. And here we first of all create a connector config, and this is from that Debezium TestContainers library. So you say for JDBC connector and pass your database connector here, so it knows how to connect to your database. But basically, it's just pre-configuring your connector with some database credentials and database information. Yeah, and after that, some properties. And the best way to learn about properties is just go to this documentation and scroll a bit, and you'll get all properties defined here with pretty good docs. So just go there and check. Yeah, and after that, you run this register connector on your test container for Kafka Connect, and the name of the connector will be this one. Once that's done, so we finish this line, we now want to block our test and make sure that our connector is successfully registered and in running state. So this library provides these functions to ensure connector and ensure state. So it basically is basically doing wait and waits for configured amount of time, and then it checks the status. So I'm using this 3 functions to ensure that it's registered, ensure that it is in running state, and ensure that the connected task is in running state. This is not required. I was just was interested to see if that's what I expect. But basically, you can get the status, they can get the task state, and get registered connector list and compare that if you want. So after that, we have our insert into outbox table. So as you can see, we generate ID. We set the aggregate type to be order and type to be order created, and some simple payload with 2 fields inside. After that, we just validate that we have something in our outbox table, that this was successfully inserted. And after that, we start our test machine from Jackdaw library. So it basically knows how to connect to Kafka. It will create a pair of producer and consumer. We don't need producer here, but we'll use consumer to subscribe it to the output topic. And then we will use a watch command, and we'll run tests with that command. So basically what that will do is it will wait this amount of time maximum for this condition to be true. So that means when we have one event in our output topic, we will exit this one and we'll say that watch command is successful, and we can access the watch results. So yeah, if you want to learn more about Jackdaw, there's a video on the channel already, so just go check that out. If you don't want to use this library, if you don't want to use this library, you can just use plain Kafka consumer, subscribe to the topic and do the poll loop, and just wait for the first event to appear and then stop. You will just need to write some helper functions and your own code a bit more. Okay, so when we getting the Kafka record, we can validate the format. And first of all, I removed this extra config to enable outbox button, but we will take a look what we get if we just insert the message in the table and how the output will look. So let's run the test and see how it goes. So yeah, it takes a while because I removed the property to use reusable containers, so it all starts Kafka all the time. Actually, we can check that by running docker ps, and we should see a bunch of containers here started seconds ago. So we have Kafka, Kafka Connect, Postgres, and this orchestration container for test containers. Okay, so let's see. me a sec. Okay, so now we're getting some event back, and you see the result. So we have the key, and that will be our UID of the event. And then we have this topic and some value in the payload. Actually, we can try to decode JSON and see what's inside. So I think it was just value. So we need JSON decode and then value from Kafka record and true to convert it to keywords. Let's try that again. Okay, here we go. Let's see. So yeah, now we have more readable data structure here. That's what basically you getting from raw Debezium connector, and it's mostly useful when you have your source table, not just like outbox button when you have kind of immutable rows, but if you have some mutable data in your table and you're updating stuff and you want all these changes to go as events into Kafka, this is quite handy because it will provide you information like after and before. So before, it will be the state of the database row before the change, and after, obviously after the change. So, and then you'll have this operation. C stands for create, but also you will get updates if it was an update. Also, you'll have a delete. So for delete, it will be after nil, and before it was the state before it was deleted. For update, it will be after and before, not nils. And then there is a specific one, which is just R, I believe, and it is when your connector is reading the initial snapshot. So you can add your connector to existing database and configure it to get all your data from your table and publish it to Kafka as an initial run. And after that, you'll get a bunch of metadata, transaction ID, some other stuff. So really, for consumers, probably that not you want if you're using the outbox button. And let's change that and see the difference. So we don't want this now, but I want to add this payload. So what we're doing is we're getting value, decoding it, and it will be different now. So to do that, we want to enable our additional properties. So let's do this. So these two lines will enable outbox transformation pattern. And this line will get our payload from database, but instead of putting it as the encrypted string into the Kafka payload, it will decrypt it into JSON and will put it as a JSON there. So when we decrypt it from Kafka, it will look like a Clojure map, because it will be single time encrypted JSON, not like double time encrypted by default. So that's good. And also we need to change this one. So default topic was using this app, which is configured here as the topic prefix, but now we'll have a different output, and the topic will actually be outbox.event.order, and order is our aggregate type. So yeah, let's try and see if that works. All right. So now you see this is passing. So basically it means that we decrypted the value, and it's exactly the payload that we put in our outbox table. This is item and price. And we can double check that in this message. So now you see it's different. We have now headers, and we have now value, and we have the payload there as the JSON string. The headers thing is interesting. It always puts the outbox row ID into the header by default, but also you can configure your connector with an additional property, and you can say that you want additional placement and you want your type field to be in the header. You want your created add to be in the header. And also there's a syntax, I believe it's something like this. When you can created add, you can rename the field how it will be named in the header if you want. But if you want the same name, you just use this field name from the table and then placement. So it could be not just header, it supports also an envelope. It will just nest the data in your Kafka message payload. But we're mostly using the headers for additional information. So now we can use this one and see the result. Let's run it once again. All right, so this is still passing. And here in the headers, now you see we have created add, ID, and type. So in addition to payload, you can pass additional information to your Kafka messages, but with a different mechanism, not putting it into the value of the Kafka record, but into the headers. Right. So I think that's it for the demo. I highly recommend to go and check all the links I'll share. And if you have some similar architecture, if you're using relational databases and you want to use Kafka as the message broker and you looking for a reliable way to share data like that, I think that the Debezium is a really interesting project. It is really popular and trusted, so I know a lot of users of that in big companies, and we also rely on this technology a lot. So hope that was interesting for someone. Don't forget to like, subscribe, and comment. And I always remind you that there is an option to support me on Buy Me a Coffee. Links are in the description. And yeah, thanks a lot. See you next video. Bye bye.